Hi guys, so in this video I'm going to be teaching you about numerical integration, how to use it to solve basic integration problems on an FRQ as well as Riemann sum problems. Okay, so let me start by saying what it is. Numerical integration is when you're finding the approximate value of an integral of a function over some domain or your bounds when you're given a table like this instead of the actual function. Let's start with a basic problem. Most of the time they're going to ask you to find the value of f prime of some number that's not in the table. In this case, I'm going to use 7. And in order to solve this, you're going to have to use mean value theorem. And the way you want to set this up is you want to write it out. F prime of 7 is approximately equal to a value that's higher than the one that you're trying to find, in this case f of 9, since it is the closest one to 7, minus f of a value that is lower than the one you're trying to find, in this case f of 6. And then you want to divide that by the actual values, 9 minus 6. And then you just work it out. That's 4 minus a negative 1 over 9 minus 6. See, 9, 4, 6, negative 1, and that equals 5/3, and that's your answer. You're done with that problem. Another common problem that shows up that I think is a little more difficult but not really all that challenging is something like this. They would give you this expression right here, which this is the integral from 3 to 14 of, this is a parentheses, 5 minus 6 times f prime of x dx. Now, obviously, if you have no idea what you're doing, you're not going to be able to do this problem. But back when we were learning how to do basic integration, you learned that you can separate when you have a plus or minus sign in between. So that's what I went ahead and did, because I think that's the easiest way to do this kind of problem. So I separated into the integral from 3 to 14 of 5 dx minus 6. 6 comes out front because it is a constant, times the integral from 3 to 14 of f prime of x dx. So you went ahead and worked it out, and you got 5x 3 14 minus 6. Now for this kind of problem, you have to know that when you take the integral of a derivative, it just equals the function. That's where I got f of 14 minus f of 3 from, because this would just be f of x minus another f of x. So that's what I went ahead and did. And then I went ahead and plugged in the values of f of 14, which is 7, and f of 3, which is 2. And then I plugged in 3 here and 14 there. And this is what I got. 5, 14 minus 5 times 3. I went ahead and combined it. 5 times 14 minus 3 equals 55 minus 6, 7 minus 2. And then it's just basic multiplication and subtraction, and 25 will be your answer. Alright, pretty simple, right? Okay, so now let's go into how to do a left and right Riemann sum. I'll also be covering how to do midpoint and trapezoidal sums, but those are going to be two separate videos, so if you want to go ahead and learn about those, you might want to skip ahead. Alright, so when you're doing a normal left or right Riemann sum, the way you're going to find the area is by using rectangles, or specifically the area of a rectangle, which is width times height. And if you had a graph with a function, this is what it would look like. So you're trying to find the area of this particular region right here. You would draw your rectangles and then use area of a rectangle in order to find the area of the whole region. Now, it's not going to be exact because you have little spots right here, here, and here that stick out of the actual region. So it's going to be pretty close. Alright. So let's go ahead and do a right Riemann sum. There is a difference between right and left. I'm going to explain that in a minute. I went ahead and I redrew the table up here. And the way it's going to be phrased on an FRQ question is typically it's going to ask you something like, use a right Riemann sum with subintervals by the dat in the table to approximate this integral. Now, when it says subintervals, all it means is these right here. From the x values from like 3 to 4, that would be one interval. 4 to 6, that would be another interval, and that's all that it means, so on and so forth. Now, the formula, like I said, is area of a rectangle equals width times height. When you're talking in terms of a table like this, your change in your x value is going to be your width, and your f of x value is going to be your height. So the way it looks when you draw it all out is you write the integral, which is approximately equal to f of 4. We start with this one because it is a right ream-run sum, so you're going to leave out this part. F of 4, which is your height, times 4 minus 3, which is your change in your x value or your width, and then plus the next rectangle, which you just do the same thing. F of 6 times 6 minus 4 plus f of 9 minus 9 minus, times 9 minus 6 plus f of 14 times 14 minus 9. And then I went ahead and simplified it, equals 5 times 1 plus negative 1 times 2 plus 4 times 3 plus 7 times 5 equals this, and your answer would be 50. So that's how you do a right ream-run sum. And if it asks you to do a left instead of a right, all you would change up is you start with f of 3 and you're going to leave out f of 14. So your width, though, stays the same, but your height is the one that's going to change. So f of 3 times 4 minus 3 plus f of 4 times 6 minus 4 plus f of 6 times 9 minus 6 plus this should be f of 9 right here. F of 9 times 14 minus 9. My mistake. And then that would be equal to 2 times 1 plus 5 times 2 plus negative 1 times 3 plus 4 times 5 equals this, and your final answer would be 29. Okay? So that's how you do left and right ream-run sums, and I'll be covering midpoint and trapezoidal sums in other videos. Alright, thanks y'all.